Okay, in this exciting math video, we're going to review solving systems of equations. And in this example, the given system and the two equations in it are in standard form, which is the ax plus by equals c form. And we can solve it as is, or we could translate them both to slope-intercept form and work with them that way if we wanted to. I'm going to start by leaving them in standard form and working with them that way. So to do that, we end up finding the x and y intercept of each individual equation. So I'm going to take the first equation in here, marked by that red dot, and look at it. And this might look like a lot of work, but really you can do this in your head once you see what's going on. The first thing you're going to do is put a 0 in for the x if you want to find y, or put 0 in for y if you want to find the x. And what you're finding is the x-intercept and the y-intercept when you do that. So for instance, if I put 0 in for x, the x term has been now zeroed out, if you will, and all that you're left with is 3y equals 6. So divide both sides by 3 and you get y equals 2. And then we'll go back, and with the same equation, we're going to put 0 in for y. So the y term is gone now, and we're left with, whoops, oh, smartboard, eraser. Okay. We're left with that negative 2x equals 6. Divide both sides by negative 2. You get x equals negative 3. And again, this is the y-intercept and the x-intercept. So where the lines, or where the line for this equation crosses the y-axis and the x-axis. Now, with the other equation, marked by the blue dot, negative 2x plus y equals negative 6. So we'll substitute 0 in for x. And of course, negative 2 times 0 is 0. So y equals negative 6. That was nice and fast. That's our y-intercept. And now I'll put 0 in for y. And almost as easy and quick, divide both sides by negative 2. Get x equals 3. So now we have the pairs of x and y intercepts for both equations. Go to that and there. All right, so red. The y-intercept is at 2, so we'll go over here, and on the y-axis, I'm going to put a point at 2, and the x-intercept is at negative 3, so on the x-axis, we'll go to negative 3, put a point here. And as we know, rise over run is slope, and I can see between these 2 points the rise. Well, it's really big, thick. Okay, anyhow, rise and run. It's up 2 and over 3. So I'm just going to continue that pattern up 2 over 3 and mark a few points all the way along here. So up 2 over 3, put another point, up 2 over 3, put a point, up 2 over 3, put a point there. Just to make sure, especially when you're sketching a line with even a ruler, it can be difficult. And I can put the line in, make this a little less. Make sure it crosses through all those points. And then we'll do the same thing for the blue. Y-intercept is negative 6, so on the y-axis we'll put a point at negative 6. And x-intercept is 3. This one we have a rise. Sorry about that, but rise of 6 and a run of 3. Not a very even line there, but rise 6 and over 3. All right, so that's what we got to do. We'll do that with my blue pen. Okay. I'll do that again. Rise 6, so right up to 6, and over 3, and bingo. Actually, we found the intersection point by doing that, and I can't proceed again because I'll go off this grid. But I've got all the points I need, and I also happen to have found the intersection point, which is the solution to this system of equations. So just go back, put this line in now. See how everything lines up. There we go. And here, we'll use this creative pen. Never get to use this dumb thing right there. Bingo. So we find out that the solution is 6 over and 6 up. Okay, and that's the solution to the system. What that tells us is if we put 6 in for x and for y, in both of these equations, we'll end up with 6, assuming we've done it right. Negative 2 times 6 is negative 12. Negative 12 plus 3 times 6 is 18, so negative 12 plus 18 is 6. And over here in the second equation, again, both x and y are 6. Negative 2 times 6 is negative 12. Negative 12 plus 6 is negative 6. So the x being 6 and the y being 6, it is a solution that works for both equations in this system. Now, for those people that don't like doing the x and y intercepts on these equations, you could take our original equations and you could translate them to slope-intercept form, and we've done that before too. If you would rather, we can take negative 2x plus 3y equals here, let me, oh, okay, here, hold on, let me make this a single page so I can see this myself a little better. Negative 2x plus 3y, don't mind me, well, you get to watch me while I'm erasing. I'm going to go back and copy this original equation and move it down a second so I can actually see what I'm doing here. It's always a little more challenging on using a tablet at home, and presents its own challenges. All right, so here's our original equations. Grab a pen, here we go. All right, so we've got negative 2x plus 3y equals 6. We know that standard, slope-intercept form is y equals mx plus b. So if you would rather work with that, what we're going to do is add 2x to both sides. Now we'll have 3y equals 6 plus 2x. Divide by 3. Everything gets divided by 3. So y equals 2 plus 2/3 x. Pretty much we're done. It's in slope-intercept form. If you want to change the position of both these terms, you could flip-flop them. The commutative property, since we're adding 2/3 x can move to the front and positive 2 can move to the back. So now it's in slope-intercept form perfectly, negative 2x plus y in terms of format. Here we'll add 2x to both sides. So we get y alone, negative 6 plus 2x. And again, we just, since we've got its addition, and addition's commutative, we can just move those terms around. Now, now the equations are in slope-intercept form, and you might remember that that the m is the slope, rise over run, and the b is the slope, is the y-intercept. So we go back to our equations. What you would do is go for the first equation, go up to 2. Find a pen here. I'm running out of colors. We'll go to this purple one. All right. So we go to 2 on the y for the y-intercept, which is right here where we were before, and then rise over run. So up 2 over 3. So rise 2 over 3 is right there. Rise 2 over 3 right there on the star. And you can see that we're graphing the same line. The same thing for the other equation. Our y-intercept is -6. We know that from before when we found it using standard form, but there it is at -6. And now slope this time is 2, so we can treat that as 2 over 1. So we got rise 2, run 1. So up 2 over 1, put a point. Up 2 over 1, put a point. Up 2 over 1, point. 2, 1, 2, 1, 2, 1. And there's that same intersection point. So you can get to the same solution either way. And whatever method makes sense to you or seems quicker or easier is perfectly fine. Now, solving them other ways, we can get, let's see here, get them back, good, there. There. It'd be nice if those dashed lines would go away. Any day now, computer. Oh good, it's going to keep them for us. Isn't that a nice surprise? Let's see if they go away, if I go back and forward. Nope, they're still there. Okay, hold on. I'll pause this and try and fix it. Okay, there we go. So we want to solve it by combining. What we can do here is if we see any terms that if we were to add or subtract would eliminate or combine and go away by zeroing out, then we're good. In this case, no, because there's no way. If I add the two x's will be -4x, and if I subtract, well, actually that will work. So good, we can subtract. So sometimes you just have to stop and think about for a moment what your possibilities are. I was thinking we might have to make equivalent equations, but we don't. So what we're going to do is subtract. Sometimes people hate this because you're dealing with these integers and the integer rules again. But -2x, subtract -2x. If you want to, think about what happens when you do subtracting a negative. And you can do keep add opposite if you would like. So keep the first term, change that to adding, and then the opposite. You can see what will happen there. Property of opposites. You get 0 when you add those together. So our x term, goodbye. 3y minus y leaves us 2y. And then 6 minus -6 is 12. And then we can divide by 2, y equals 6. So that's our y. We can go and take that and we'll put it into either one of the equations, whichever one you like, because I'm going to put it into this one. So my equation, -2x plus 6 equals -6. Well, that's a stretchy x. So -2x. Well, actually, let's do this. We have to subtract that 6 first. So subtract 6 from here, subtract 6 from there. So we've got -2x equals -12. Divide by -2, divide by -2, x equals 6. And there we go. We've got our solution again for this equation being 6 and 6. All right, so we did that through subtracting the two terms, the two equations, so that we could eliminate a term. In this case, it was the x term. And finally, we can do the substitution method. There's a lot of, like any of these, there's a lot of ways you could solve. Let's see. Here we go. Okay, there. We need these to be written in terms of either x or y. So actually, in this case, it would be helpful for us to go back to the rewritten equations down here when we rewrote them in slope-intercept form, because they're both written in terms of y. Y equals 2/3 x plus 2, and y equals 2x plus negative 6. Since I've already taken the time to write them in that format, I think I'll just work from this page. So here we go. We've got our system. It's been rewritten in slope-intercept form. And we need to think about this in terms of, well, if y, both here, y equals this equation, 2/3 x plus 2, and it also equals this equation, or portion of the equation, 2x plus negative 6, well, then we can set them equal to each other. And that's what we're going to do. Keep going with red, I guess. 2/3 x plus 2 is equal to 2x plus negative 6. Now, this is one of those occasions where if you want to, a lot of people hate working with fractions and all this stuff going on here. What we can do is multiply everything by 3. So if I multiply by 3, that's going to eliminate the division of 3. So 3 times 2 is 6. 6 divided by 3 is 2. And of course we have the x is still there. So that just takes care of the fraction for us. And that's true for any situation where you have a fraction. If you multiply by the denominator, you will end up with the numerator. So we got 2x, and everything else also needs to be multiplied by 3. So that's 6x, and this is negative 18. All right, now it'll be a little easier to work on this equation. You don't have to. Some people like to convert these to decimals. Problem with that is, of course, we can't jot down 0.6 repeating forever, so it gets we can lose some accuracy there. So I'd prefer to work with the whole numbers, unless it's a perfect terminating decimal there. 2x plus 6 equals, okay, so let's do this. We need to combine all the x's. I think what I'll do is I will start off by subtracting 2x here, subtracting 2x over here. So now we have 6 equals 4x plus negative 18. And I need to move that out of the way. And okay. So now we have, shouldn't have done that. Well, it doesn't matter. It's okay, but now I end up having to move the 4x later, but oh well. Oh no, I don't. Forgive me. It's almost midnight. I've been doing math all day now. Losing my mind. All right. What we'll do is we'll add 18 over here and add 18 over here. That gives us 24 equals 4x. We'll divide by 4 on both sides. So we get 6 equals x. All right. So now we've got our x term, and we can put that into either one of the original equations. Let's take and put it into, let's avoid that fraction if we can. Let's put it up into this equation here. So we'll have y equals 2 times 6 plus negative 6. Y equals 12 plus negative 6. And y equals 6. 12 plus negative 6 is 6. And there we go. Y equals 6. So once again, and not surprising, our solution to this system is 6 for x and 6 for y. And we're good. Again, you can check that by putting those in. Put 6 in for x and 6 in for y in your equations. Both those equations should be true. It should come up with a true statement. Finally, for those of you that are using graphing calculators and you remember what we've learned in class, you can put both of those equations into the graphing calculator in slope-intercept form, hit graph, and then second function, calculate, and then it's option 5 to find the intersection. Hit enter 3 times, and boom, the calculator tells you the intersection point. And that's a good way to check your work. Don't forget there's tons of free graphing apps for your smartphones and iPods and tablets that will do just as much and sometimes even more than the classroom graphing calculators. Okay, 20 minutes later, I hope this has been somewhat helpful. If any part of it has been, good. If not, I'm sorry that you've spent your time watching this. And we will see you in class. Good luck and talk to you then. Bye.